Hi everyone, welcome back to PRAKASAM tutorials. In my previous video, we have discussed about concept of probability density function. Now here in this video, I am going to discuss about properties of probability density function. There are some important properties of the probability density function that are first one is the probability density function is always greater than or equal to 0. The probability density function is always greater than or equal to 0. That is non-zero for all values of x. That is fx of x is greater than or equal to 0 for all values of the x. So keep in mind the main difference between the main difference between probability density function and the probability distribution function in symbolically. The probability density function is represented by small fx of x or simply f of x, and probability distribution function is represented by symbolically capital Fx of x or simply capital F of x. So that is the main difference between probability density function and probability distribution function. So keep in mind this point. The concepts are very easy. Next, coming to the proof of the first property. So according to the definition of the probability density function, the probability density function is the derivative of the cumulative distribution function. The derivative of the cumulative distribution function or the derivative of the probability distribution function is always positive. So that is, so derivative of the distribution function is always positive. Therefore, the probability density function is always greater than or equal to 0. Is always positive. That is, fx of x is greater than or equal to 0 for all values of x. And this is the first property and proof. And second property, the area under the probability density function curve is always equal to unity. That is, integral minus infinity to infinity fx of x dx is equal to 1. Proof. Coming to the proof, we know that from the definition of the density function, the probability density function is the derivative of the distribution function. That is, fx of x is equal to d by dx into capital Fx of x. On integrating both sides, integral minus infinity to infinity fx of x dx is equal to integral minus infinity to infinity d by dx capital Fx of x dx. So integrating above equation on both sides, we get this is the resultant term. On RHS side, integration and differentiation is cancelled. Integration and differentiation always 0. Integration means increasing the value. Differentiation means decreasing the value. So both are opposite. So integration and differentiation is cancelled. The remaining RHS term is capital Fx of x over minus infinity to plus infinity. And after that, on RHS side, applying upper value of x and lower value of x, we get the RHS term is fx of plus infinity minus fx of minus infinity. So from the properties of the cumulative distribution function, fx of x, fx of plus infinity value is 1, fx of minus infinity value is 0. So using that property on RHS term, fx of plus infinity is 1, fx of minus infinity is 0. 1 minus 0 is equal to 1. So therefore, integral minus infinity to infinity fx of x dx is equal to 1. The small fx of x is the probability density function. The area under the probability density function curve is always equal to unity. That is, integral minus infinity to infinity fx of x dx is 1. And this is the second property. Next, coming to third property, fx of x is equal to probability of x less than or equal to x, and that is the definition of the probability distribution function, which is equal to integral minus infinity to x probability density function into dx. So that meaning is it is possible to get cumulative distribution function capital Fx of x by integrating the probability density function. This is the third property. Proof is, so we know that from the definition of the probability density function, probability density function is equal to derivative of the distribution function. Integrating this equation on both sides, we get integral of the LHS term is equal to integral of the RHS term. That is integral minus infinity to x fx of x dx is equal integral minus infinity to x d by dx into fx of x dx. So now here we want to prove that this LHS term is equal to this. And on RHS side, now what is the range of the integration? Minus infinity to x. According to the definition of probability of x less than or equal to x means that varies from minus infinity to x. So because of that, now here consider the range of the integration is minus infinity to x on both sides. And after that, on RHS side, integration and differentiation is cancelled. The remaining RHS term is probability distribution function over the interval minus infinity to x. Fx of x over minus infinity to x. Next, applying upper value and lower value of x, we get RHS term is fx of x minus fx of minus infinity. So using cumulative distribution function property, the value of fx of minus infinity is 0. So therefore, LHS term integral minus infinity to x fx of x dx is equal to fx of x minus 0. Fx of minus infinity is 0. So therefore, integral minus infinity to infinity fx of x dx. So integral of the density function is equal distribution function. So from the definition of the distribution function is equal probability of the event. So that event is x less than or equal to x. This is the third property proof. Next, fourth property. If random variable capital X is a continuous random variable, probability of X is equal to X is 0 for all values of X. This is the fourth property of the probability density function. Next, fifth property. The probability of the event between the interval, so that interval is x1 to x2, that event is x1 less than x less than or equal to x2, is given by the area under the probability density function curve in the event x1 less than x less than or equal to x2. So that is mathematically integral x1 to x2 fx of x dx density function dx is equal probability of x1 less than x less than or equal to x2. So now here the range of the interval x is varies between x1 to x2. In second property, the area under the probability density function is always unity, that is integral minus infinity to infinity fx of density function dx is equal to 1. And third property, probability of x less than or equal to x, that meaning is minus infinity to x. In that property, the range of the integration is minus infinity to x. Now here the random variable x is varies between two interval, that is x1 to x2. Now coming to the proof, we know that the probability density function is the derivative of the distribution function. So integrating on both sides of this equation for the interval x1 to x2, we get this is the expression. On RHS side, differentiation and integration is cancelled. The remaining RHS term is cumulative distribution function over the interval x1 to x2. And after that, on RHS side, applying upper value of x and lower value of x, we get the resultant RHS term is fx of x2 minus fx of x1. But we know that from the one of the property of the probability distribution function or the cumulative distribution function, fx of x2 minus fx of x1 is probability of x1 less than x less than or equal to x2. So this is the fifth property of the probability density function. So these are the properties of the probability density function. So these properties are very important.